guys know who I am. The breadcrumbs are at the top. Take a screenshot if you want to get in touch with me. The subject matter, optical, comparator, lathe form tools. That's what I'm on a fishing expedition, trying to see if this content will get some traction, all right? I'm not going to waste a lot of time here. Your comments will tell me whether I should go forward or not. All right. What I'm showing you here is a drawing. It's a lathe job. This is all on diameter. You can see all the diameter insignias there, all right? IDs, ODs, all that shit. All right? What I got to do is I got to make some form tools that are precisely located. I'm going to show you how a comparator can really help you. Alright, this is a drawing of what you just looked at, that red obnoxious drawing I sent you. You see it? Diameter, that's all diameter. This is the lathe axis here, you see it? Alright, just getting you oriented. These are 3/8 form tools, you see them? They're 3 inches long. I broke it here so I can manipulate this CAD system to do what I want. Alright, well, let me do this. Well, let me go back. I missed a step here. See, let me get this in red. What's this radius here? See, what is it? 45 thousandths. You see it? What's this radius here? 10 thousandths. Alright? What's this radius here? 24 thousandths. Just giving you an idea that this is small stuff. What the hell's going on? Alright. It wouldn't hurt if I knew what I was doing. So now, with the help of a comparator, let's be presumptuous. You see these form tools, that shape there? Well, let me give you this dimension. 45, just like the females, half of that, alright? Another form tool, this has got 10 thousandths on the tip. See that? That was the other corner. And the other one was that little ball dimension. .24 radius, 48 ball. Okay, the reason I say 48 ball is I'll show you. See it right here? 48 ball tool or 24 radius. Alright, let me show you how the comparator is going to help you. Alright? Assuming that you got the form tools that I show here. Alright? I want to drag this by hand for now. How do I locate this? You see, this matches that. I'm going to come in. Using the comparator, I can touch off. It's got a readout on it and an XY table. I can touch off here, go in there. I can touch off here. I can touch off anywhere, and that comparator readout will tell me where I am. So what I'm going to tell you is, here's the plan. You come in here, you go in there, you don't touch there, you come out, right? You can locate from the OD, you can locate from under there with this ball, with this tool, all right? Let me go, to show you this other tool. I'm going to go get that 10 thousandths radius. I'm going to bore and get that radius at the same time. You see, with this tool, I'm going to come in here and I'm going to bore. When I hit the corner, I'm going to paste. See, it can come down quite a bit. See it? Right? Without hitting that corner of the radius. I'm just prepping you, showing you where we're going before I show you the comparator. Obviously, to locate this, we'd have this diameter done and that diameter done. You just touch off, come in, come right in here and finish the sucker, one plunge cut. Alright? That's the basic moves you're going to make. Them are the tools you're going to need. Let me show you the comparator. This is a typical optical comparator. This one happens to have a 14-inch screen. See, it says 14-inch. It's got all these lines on it. See these lines and this arrow. This outer, that's an outer ring with all the graduations on it, right? Just giving you an idea what it looks like. All right. Now, how am I going to do that? How am I going to touch off? Here's what I made. Using my CAD system and a printer, I print a clear see-through overlay. See, it says 20:1. I printed up 20 times its size. I'm showing it now at 20 times its size. See it here? That's an overlay. Over here, I just took that overlay and placed it on these lines here. See? Everything lines up. You understand? Now I can take the tool and using the XY stage or table, it moves in this direction and in that direction, and as it moves, it monitors. It works like a readout, all right? Let me show you more or less. Well, let me give you an idea about how big it looks. That's a 3/8 tool, but I'm showing it 20 times bigger on the screen. Let me show you this. This is the actual size on the screen of a 3/8 tool. You see the shape of that tool, 3 inches long? See that shape right there? Well, let me just, that shape there where the mouse is the same shape here. The shape's 20 times bigger, just to give you an idea. Alright? Now here's what I do on the optical comparator. Alright, I'm going to put this radius, which is 20 times bigger than the drawing, onto this onto this optical comparator, which is 20 times bigger, and I'll show you how it goes. You see it? It just fits in there, all right? Now I'm gonna bring this down and face this. You see it right there when I face that. It's being monitored all the time. Oh, you stupid. You see it? I can tell by looking at the readout how much movement I can make on that, right? Matter of fact, I can tell you right now. Once I get it the right diameter, I can move it an inch and a quarter divided by 20, whatever the hell that is. I don't know. But you understand? All right? Just trying to show you how we go about it and how the optical comparator is the key with the layout. This happens to be a 20-to-1 blow up. I have another lens that'll have a 10-to-1 blow up. It depends how big the shape is you're putting on that optical comparator. All right. Anyways, I'm trying to figure out, did I cover everything? I guess I got it all. All right?